So iterator methods we can see now. So what are the different iterator methods? So let's go and see iterator methods. So iterator is another interface. Basically, it iterates the collection elements one by one, automatically in forward direction. So not in reverse direction, but in forward direction. So let's see here, iterator interface. So this provides the facility to iterate the elements in forward direction. That means only one direction you can iterate. First element to last element. So that's the iterator interface purpose. It provides few methods. So let's go and discuss one by one. So first one is has a next method. Has a next method. So it returns true if an iterator has more elements. So it just, you are calling, right? Iterator method you are calling. First you have to call iterator method on the collection. So then the value will be stored in the first element will store in the IT. So while you have to use a while loop, while it dot has next. Has next method checks this it variable has a value or not. If it is there, then you can fetch that value with a next method. So the next method, it returns the IT value and the cursor will move to next position of this collection. So the next element, it will move. Then this iterator will fetch that next element, stores here, and then it keeps checking the element available, comes inside, get that value. So this is how you can get all the element values. Okay, so this is the very important structure. You need to remember this. Any questions here? Okay. So till now we have seen collection interface methods, iterator interface, how to iterate the collection we have seen, and collection hierarchy of all the classes we have seen. So the interfaces and so different interfaces and different classes we have seen. Now, first interface, that is a list interface. So list interface is a sub-interface of collection. So list is a sub-interface of collection. It contains index-based methods to insert, access, and delete the elements. Basically, collection interface has only elements, right? Directly you are inserting the elements. There is no index-based methods in the collection interface. But in the list interface, you can insert the elements or access the elements, delete the elements based on the index. So index-based methods are provided in the list interface. So list is a sub-interface of a collection interface, which contains the methods to access, insert, delete the elements based on the index. That means, so randomly you can pick also from the collection. If that collection type is of list, because it works based on the index. And collection, the list collection contains a duplicate elements. That means you can insert the duplicate elements in the collection. You can insert the elements. You can insert the elements, duplicates also. So that's the list collection. And also it maintains the insertion order. Which order you inserted, same order it will return to you. These are the points you need to remember about list collection. So the list collection methods you can see. So first structure you observe. Public interface list. So this is the a generic type. The angular bracket inside is a element type, basically a type. Extends collection interface. That's what I told you. Interface extends another interface, right? So one interface extends to multiple interfaces. That is possible. And here, see, the element data type is E. So this is the data type, element E. So add method, add int index element. Boolean add element. So add all. So can you observe here? So add all int index collection C. So add method int index element. Add, so this E. So add all collection C. Add all int index collection C. So can you observe here? These two are coming from collection interface, and this one is declared in the list interface, and this one. Wherever index based methods are there, that are belongs to list, and other methods are coming from this inheritance, right? This one, inheritance, right? So list also can get all the collection methods. Clear method, it clears all the elements. Equals method, it compares. Hash code method, so fetches the hash code of the object. So get method int index, and boolean is empty, so returns so true if the list is empty, otherwise false. So int last index of, so last index of means basically you can find the given object last index. So this is a very important get method. So you give the index number, on that place what element is there, it will fetch for us. There's a list dot get method. So it returns the element. So on that index, that's the get method. Very important method. If you're using a list, means list dot get. So all these methods are list object dot get. They're non-static methods, right? So you will create object for interface reference variable equal to new implementing class objects. Which class you want to implement object, that class you implement object, then you can call that. That's the get method purpose. So to array, so it will convert the list collection into array format. So to array, so another one, so it contains the all elements in the list in the correct order. So contains method, even we have contains in the list, right? Collection, same here. So here we have a contains all. So all this collection of elements are there in the list collection or not, you can check it. And index of method. So index of this object index, you can find it out. This object index, you can find it out. Remove method, say remove int index. So given position, what element is there, that element you can remove it. That's a remove int index. Remove all collection C. So it is used to remove all the elements from the list. So it is used to remove all the elements from the list. So you can use remove all. So there is a one more method, set method. Set method int index element. You can set the element in this position using set method. So that's one important. These are the some of the things most important. Size method. You can find the number of elements in the collection. So very high level, list is a sub interface which contains the duplicate elements, which is mainly used to insert, delete, access elements, get the elements from the collection based on the index, because the list works based on the index. Simply say that word. And List is an ordered collection. Which order you inserted, same order will be returned to you. So list contains a duplicate elements. So that's all about list interface. List extends to collection interface. So list is a sub interface of collection interface. So list is implemented in array list class, linked list class, vector classes. So which classes the list interface is implemented? Array list, linked list, vector. These are the classes the list is implemented. Okay, so how can you iterate the list interface, list collection? There is a one more provided, list iterator interface. So list iterator extends to iterator interface. So iterator just now we have seen, right? Iterator you can use to iterate any collection. So it can be a list or a set, any collection you can iterate. So that is the iterator interface. But list iterator, you can iterate only list collection. But a list iterator is a sub interface of iterator. So list iterator has a few methods because this iterator has next to next method, right? And this list iterator has previous to previous. That means previous elements you can access, next elements you can access. So that means it has a backward and forward direction. You can traverse the list collection elements. That's the list iterator. List iterator mainly used to traverse the elements in a backward and forward direction. That's a list iterator. Okay. So what is array list class? So first class, so which is implemented the list interface and collection interface. You can see so array list extends to abstract list. So and implements the list interface. List is extends to collection, collection is extends to iterable. This is the hierarchy of so classes and interfaces. And array list class uses a dynamic array for storing the elements. So it inherits the abstract list class and implement the list interface. So some of the important points about array list is, so you know array, right? Array will just stores all the elements, but fixed size. So you are giving for the array. But here it's a dynamic array. It stores the elements automatically when you are adding them into the array list, but a dynamic. You don't need to specify the size. So it's so expandable and collapsible. That's the array list. So array list class, so array list extends abstract list, implements list interface. So on the constructor of array list is, see, this is the default constructor, a constructor with the collection, constructor with the int capacity. So this is the constructors of so array list. So methods of Java array list, methods of Java array list. So same methods, whatever we discussed just now, right, in the list, same methods will be there. So separately you don't need to discuss, but you need to understand these points. These points are important. We didn't discuss, right? Let's go and discuss. Array list class contains duplicates because list contains duplicates, right? array list class also contains duplicate elements. So array list class maintains insertion order. So array list class is non-synchronized. So array list allows random access because array works at the index basis. So array works based on the index basis. So but array list is a non-synchronized, and it also contains duplicate elements, maintains the insertion order. So random access is possible because array works based on the index. So array list works based on the index. So the manipulation is slow because a lot of shifting needs to occur if any element is removed from the array list. For example, middle one element is removed, so the next elements will move to that position. So that takes some time, right? So that's why manipulation is bit slow in the array list. So if you see hierarchy of array list class, public class, array list, extends, abstract list class, implements, list, random access, clonable, serializable. All these interfaces are implemented in the array list class. And also abstract list class methods also implemented here. So this is the abstract class. Abstract list is an abstract class. So that class also implemented in this array list class. And next, linked list. So this is the important interview question between array list and linked list differences they are asking. What is the difference between array list and linked list? So linked list is basically stores the elements in both ways. Front and back also you can insert the elements. It's a kind of linking. Linked list data structure. Okay. So it inherits the abstract list class and implement the list interface and the DQ interface. Linked list is going to implement both interfaces, list to DQ interfaces. Both will be implemented in the linked list class. So observe the differences. Array list and linked list. Array list also has a duplicates. Linked list also has a duplicates. So array list maintains the insertion order. Linked list also maintains the insertion order. Array list is also non-synchronized. Linked list also non-synchronized. First 3 points are common. Fourth point, manipulation is slow in the array list, but manipulation is faster in the linked list because no shifting required here in the linked list. So you can use a linked list class as a list, stack, or queue. Any of these three, you can use the linked list. So that's the advantage with this linked list. So that's the main difference. The manipulation is faster in the linked list, and it will be used as a list, stack, or queue, any one of them. And so this is the hierarchy. Public class linked list extends, abstract sequential list, implements, list to DQ, clonable, serializable. And these are the constructors. This is the constructor overloading also. Same, almost similar method, but the extra methods you have here. Add first to add last. You can add first also, you can add last also, you can add using these methods. Elements you can add, I told, right? Both ways you can add. So that's another thing. So you can get the element int index, get first, get last. So index of method, last index of. So list iterator. So and peek, and these are the important. Peek, poll, pop. So these three methods important. Peek, it retrieves the first element of a list. Poll, it retrieves and removes the first element of a list. Pop, it pops an element from the stack represented by a list. So these are important when you're using as a stack. So you can use linked list as a stack, right? That time you will use these methods, peek, for, loop, pop. These methods you will use. So, and another one, push. It pushes an element onto the stack. So even this also you will use along with the stack, these methods when you're working with a stack. Okay. So next, vector class. So vector class is another dynamic array to store the elements. It is similar to array list, but there is a small difference. Array list is a non-synchronized, but vector is a synchronized class. That's the main difference. Okay. And what is a stack? Stack is a subclass of a vector class. So basically, stack will implement last in, first out data structure, LIFO. So LIFO means last in, first out order. Like, example is a go down. So if you take a go down, so the element which is going into the go down are goods going in. So last element will be taken first out, right? So that's one example for stack. So the stack contains all of the methods like a vector class methods, and also provides method like a push, peek, so pop. These are the methods you will use in the stack. Just now I explained. Peek, pop, so push, these methods. You can push the element into the stack. You can pop up the element. That means you are taking up. So that these are the methods important when you're working with a stack. Then what is queue? So queue is basically another interface, so which maintains the first in, first out order. Like wherever you are standing in the queue, if you are in the first, you will be out first. So that's a queue also similar. The elements first in, first out order. So it can be, so is ordered list, so that holds the elements which are about to be processed. So that's the, there are various classes implemented this queue interface like priority queue, and so DQ is implemented array DQ. So these are the, so queue interface related. And this one, array list and linked list differences. Again, one more time, let me recollect once again. Array list is internally uses a dynamic array to store the elements. Linked list internally uses a doubly linked list to store the elements. That's the first point. Okay, there's a difference, right? How it will store the elements. Second point, manipulation is slow in case of array list, because so if some element is removed, all the bits will move here and there. So manipulation is very faster than array list because it's a doubly linked list. So no bit shifting required in the memory. So third point, array list class acts as a list only because it implements the list. So linked list class can act as a list, queue, both because it implements the list and DQ interfaces. And array list is better for storing and processing the data. Linked list is better for manipulating the data. So linked list is better for manipulating the data. So that is the main concept of this linked list. Okay, so this in the interviews also asked many times. Please read this theory part. Don't neglect, because so even recently also I attended one that they also asked this question. Okay, and so generics and non-generics. What is mean by generics and non-generics? Any questions before going for this? I just explained list only. List collection interfaces that implemented classes only I explained till now, and collection methods. Now let's go and discuss on what is generics, non-generics. So generics means, so basically this is till JDK 1.5, this, so non-generic concept only people were using, but in the 1.5 onwards, generic concept is implemented. So basically generic concept allows you to have only one type of objects in the collection. So it's a type safe. So no need to do a typecasting at runtime. So that's the main advantage of generics. Otherwise, you can store any kind of elements in the collection. So you can store any kind of objects or elements. But I want only one type of data I want. Then how can you do that? So that you strictly can tell that, okay, I want only string type, I want only integer type, I want only double type. So how can you strictly tell that? So that is called generics. So you can tell that type of elements in your collection, you can have them. So that is called generics. So basically it, stronger type checks at compile time. So compile time itself, it will check whether it is a specified data type elements are there or not in the collection. So if you make any mistake, it will throw a compile time error. So elimination of typecasting you can eliminate if you specify the generics. That's one good advantage here. You can eliminate the typecasting concept if the generics. So when rewritten to use generics, the code doesn't require casting. So like this. See here you don't need a here you need a typecasting, but here, so if you are specifying in the Angular brackets the data type while creating the object itself, so then you don't need to do a typecasting. But here, see, we did a typecasting because here this is the non-generic format. So can you observe this line and this line? Okay, so the difference you can easily check that. So observe this one and this one. See what is the difference. Here this is the non-generic and this is the generic. Generic, how you can specify interface after Angular bracket inside the data type. So that's the generic. So both sides you will specify, left hand side and right hand side. So here also you have, right? And here also you have. This is the called generics. And this is the non-generic format. This is the generic format. So that's all how you can specify a generics. So this is the one. So non-generic format. And this is the array list string AL equal to new array list. This is the generic format. So in generic, so we specify the type in Angular braces in both left and right hand side. And so you can say the array list here you are forcing this AL collection have only string type. If you try to add another type of elements, it gives a compile time error. So that's the main concept of generics. And you can see here list Angular bracket to data type collection equal to, so there is a WebDriver plural methods which returns a collection interface. That's a list interface. So that interface type also this method will tell you. And same, so this is the non-generic format and this is the generic format. So even set collection also, some WebDriver methods will return a set collection. Why WebDriver methods are returning? A group of elements they will return from the web page. That time you will use this. So set data type collection name equal to new implementing class data type. So set data type collection name equal to new hash set, linked hash set, tree set. See, You can create object for hash set class, linked hash set class, or tree set classes, any class. So that is this generics, how you can specify. Any questions before going for the set interface? We'll finish this today, the theory part. Then we can go for the next class on so Monday, right? Monday means your Monday, my Monday, your Tuesday. So next class, I'm giving it 2 days. Please read, because next week we are finishing the entire Java. By that time, you should be able to be strong in Java. Then we are going to start the Selenium. Okay. So by that time, so you take time this week and next week you have time and prepare very well Java. So then once the Selenium starts, if you don't have a Java concepts, there you will face a lot of problems. You won't understand there. That's why please concentrate on Java, mainly functions, control structures, these two, and variable types. So these basics, core basics, should be 100% confident. Then only it will work out there. Okay. Yeah, let's go and finish this set. A set is an interface, so which is a sub-interface of collection interface, and which extends to collection interface. So it is going to represent unordered set of collection elements. So there is no order guarantee here. So it doesn't allow duplicate elements. So even if you insert also, it will return to you unique elements. That's the difference between set and a list. Set contains unique elements. List contains duplicate elements. List is ordered collection. Set is unordered collection. So list also works based on the index based, but set doesn't work based on the index based. You don't have any index based methods in the set collection. This is also one type of collection. Like so list is one type of collection. Set is another type of collection. So and so set is implemented by, you can see here, hash set class, linked hash set, and tree set classes. And set generic type S1 equal to new hash set generic type. So set generic type S2 equal to new linked hash set, so data type. So set data type S3 equal to new tree set data type. So this is how you can store the elements. So how you can create the set collection. Okay, different. Then what is the difference between hash set, so linked hash set, and tree set? So hash set class basically stores the elements based on the hash table concept. Hashing means memory based. It will store them. So it inherits the abstract set class and implements the set interface. So the important points of hash set is, hash set stores the elements by using a mechanism called hashing. So hash set contains unique elements only. Hash set allows null value. Hash set class is non-synchronized. Hash set doesn't maintain the insertion order, and elements are inserted in the basis of their hash code only. Hash set is best approach for search operations, and the initial default capacity of hash set is 16 elements. The load factor is 0.75. When 3/4 is filled, again one more 16 buckets will be filled automatically. So that's how hash set will be inserting the elements. And the hierarchy, if you see, hash set extends abstract set, implements a set interface, clonable and serializable. And these are the constructors. And let's see linked hash set. So linked hash set is basically it implements the set interface, but it extends the hash set class and implements the set interface. So like it maintains the insertion order basically, but the hash set doesn't maintain the insertion order. But linked hash set maintains the insertion order. And tree set is, mainly it sort the elements in the alphabetical order. Okay, so in the ascending order, they will sort it. So if you want a sorting of your collection, make sure you take the tree set class object. Then automatically the elements will be sorted and given to you. So how to convert a set into list? So list, angular bracket, the data type, collection name equal to new array list, and pass the set collection. Again, vice versa. Convert the list into set collection. You have a list, you convert that into set collection. Set data type collection name equal to new hash set, data type list collection name equal to new. So what is the difference between list and set? So as I mentioned already, list can contain duplicate elements, whereas set can contain unique elements only. List is ordered collection, set is unordered collection. So list elements can be accessed using index, whereas set collection elements cannot be accessed using index. List is implemented by array list, linked list, vector, whereas set is implemented by hash set, linked hash set, and tree set classes. So what is the difference between iterator and list iterator? So iterator can traverse the elements in forward direction, whereas list iterator can be used to traverse both forward and backward directions. So list iterator inherits the iterator interface, comes with extra functions like adding the element, replacing element, getting index position of previous and next elements. So we can use iterator to traverse both list and set collections, whereas list iterator can be used only for list. And how you can iterate the collection? So either by iterator interface or by for each loop or by normal for loop. So iterator interface is iterator it equal to collection dot iterator method, while it dot has next and get the value within next method. So for each loop is for bracket data type variable name colon the collection name. So we iterated the array also with the for each loop. So same way you can do that with a collection also you can do that. And we have a normal for loop for bracket initialization, semicolon condition, semicolon increment or decrement, statements are logic. So, but make sure all three you can use for the list, but for set, you can use only 1 and 2 only, not the third one. Why cannot use third one for set collection? Why you cannot use set for set collection third one, normal for loop? Because set doesn't work based on the index. This represent the index. That's why. So this represent the index. When you have an index, then you can use. So list has an index. That's why we're using here. Okay. So that's all about today's class. Please go through this and come back. And I'm giving 2 days, all days. I will meet on your Tuesday morning. Okay. And make sure you read all these things. Yeah. Thank you. Any questions? Okay.
Thank you